So in our previous class, we started with a VPC. We created a public subnet in that VPC. Public means anything that is publicly available. Okay, like when you say public property, it's property that is available for public use. So public subnet is something that resources which are kept in that public subnet, okay, will be available publicly for public use. Okay, that doesn't mean anybody, anywhere, anything can be done on that systems or that resources. We can still put some restrictions there. Okay, example, if I have a chair kept in my office, then anybody in my office can access it. Okay, maybe if I allow people, other people, they can also come and access it, but anybody in the world cannot come here and access that. Anybody in this entire building cannot come and access this. So I can have certain set of restrictions on these resources, but that's how it is. Okay, a public subnet will have again a CIDR. Okay, CIDR as in set of IPs that will be allotted to every resource that is kept in this. Okay, again I'll reiterate, VPC is a region specific resource. Subnet is a, I'll share my screen quickly. Can you see my screen now?
Yeah, now we can.
Cool. Thank you. So maybe with this clarity, you might not get everything related to your in your architecture, but every company will have an architectural diagram to design how their servers, how their architecture, their infrastructure will look like. Okay, we have already discussed what an infrastructure is. Now, in an AWS account, okay, in a specific region, we have created a VPC. So VPC becomes a region specific resource. Okay. Post that, we created a public subnet, which is, this is a subnet. We create, can you see subnet 1? This is a availability zone related resource. So this is available in a zone. Okay. In this particular region, in a zone, it is available. In an availability zone. We have discussed about availability zone as well before. So now when you create this, it will become complete, like initially when you create for the first time, it will always be a local one, locally available, or a private subnet. Okay, not even private, but a simple subnet which has only locally tools available. Okay, then when we attach this internet gateway and this route table, that is how we created it as a public subnet. Now how did we create it as a public subnet? By adding this component, that is, any request apart from the internal request will use internet gateway to access resources, as in any incoming, any traffic in, if on these machines, any traffic that you're trying to achieve, like if the destination is of this CIDR, because it is a VPC CIDR, then look inside. Okay, this will automatically be available every time you create a subnet. Okay, and this is what we have added to update or create a public subnet. So anything that is directly connected to an internet gateway for incoming and outgoing requests, that's how we create this particular subnet as public. Now let's look at this example. In this, we have a VPC, we have a region. Forget about this S3 gateway and all, okay, because this is not what we okay, let me try to get some image that will well resonate with what we are trying to do here today, because I don't want to actually go ahead and okay, confuse you with everything. So let's consider this. It's a very simple example. This is our AWS account. This is our VPC. This is a region specific resource which is there in AP South 1. Okay. Now we have a subnet, which is a public subnet, which has AP South, which is available in AP South 1A, that is the zone. And this is the CIDR. Now, this let's try to create most of these resources and see whether we can replicate this infrastructure. This infrastructure doesn't only have a public subnet, but it also has a private subnet. Okay. We'll discuss about each and every component in depth if you have any doubts. Okay. So again, this is how our console will look like. Right now, we are creating everything like via console. We in the next topic, as in the next tool that we'll be learning, then we will be creating all of this via a code. Okay, a code as in a simple YAML. So don't worry, simple TF file. So don't worry about it so much. Now here we are creating a VPC. So we'll be going to a VPC resource. Now in this, if you see this VPC is in AP South 1. So we'll have to be in AP South 1. Are we in AP South 1? Yes. In every region, there is going to be one default VPC that will be available. This is given to you whenever you start your account. So you can keep that. Now, first I'll create it in the way, okay, as like just as we did last time. Okay, that is a bit more automated way by just like selecting some components, and then we'll create each and every component manually also. Okay, as we did in the last class. DevOps course, public, private. Now, cider here. Why I'm trying to replicate this is because, okay, you should understand this concept, okay, but we like in general organizations, you might not get this cider right away. Okay, this is something that they might give you, but you can still decide whether you want to go for /16/24 and all of that. We'll discuss that in length. Okay. Right now, I am not going for IPv6. We have already discussed tenancy options. It is same as what we discussed last time. So tenancy can be 2, it can be default, or it can be default as in shared. Okay. Wherein your VPC resources is shared in multiple servers, and none of a dedicated server is given to you for your VPC. Okay. But in case of a dedicated environment, a dedicated AWS server will be given to you for your, or a dedicated AWS network will be given to you. You can consider that. Okay. Now here, number of AZs where we want to work with is 2. Customize, you can customize which two AZs you want to work with. Why did I take these 2 AZs? I got these 2 AZs from here. Okay. This is also something that might not be given to you, okay, initially at first hand by the organization, but using by looking at different architectures and by replicating it, you can understand the pros and cons and maybe design a few things, tweak a few things here and there. Number of public subnets. Okay. Now, if I take 2 AZ, if I select 2, okay, what it is trying to do is create 2 public subnets and 2 private subnets, which we don't want. So this is a drawback of using this. We don't get full liberty of which availability zone. We do get liberty of which availability zone we want to use it for. But in this case, it is trying to create a public and a private subnet in only this AZ. Okay, that is a problem that we'll have to solve. So we'll, as we discussed, more and more automation or other teams tools that you start using, lesser and lesser control you will get, okay, on the tool. So right now, since we are trying to create it via this, I'll tell you. Okay, so this is a public subnet cider. So this is 24. Now what is the problem? Problem here is that 168.0. So we have 256 IPs here. In this subnet, 256 in this subnet. Choose the number of availability zone. Okay. And do you want S3 endpoints? No, none. Do we have any endpoint here? S3 gateway? No, nothing. Okay, so I'm not selecting this option. As soon as you'll go ahead and select this, it will go ahead and create a subnet for you. Can you see this? DevOps course, pub, sub, private, VPC. I think, yeah, this will be better. So DevOps course VPC, then we have two subnets. Both of them are right now in this region. That's what it is mentioning. It will be creating two different route tables, one for public and one for private. Two different route tables. Can you see this? One route table, another route table. So it will create two different route tables, one for public, another one for private, and then it will create one IGW and one NAT gateway. As soon as I'll click on this, as soon as I'll click on that, it will automatically go ahead and create all of those resources for me. Okay. Yeah, it automatically picked everything. So look, it is going ahead and creating a VPC, DNS domain resolution, DNS host names, VPC. So after creating a VPC, it is creating two subnets for me, an internet gateway, attaching that internet gateway to a VPC. Okay. Then it is creating one route table for public. Associate that route table, create an elastic IP, NAT gateway activation, and then route table and route table activation. Once this is complete, this entire infrastructure will be created. Now, the only fallback here is that if you use this VPC wizard, you will not be able to, you will have lesser control over where to put which subnet. Because now, as I already mentioned, both of them were in the same subnet, which is what the problem was. And that is usually a general case that you create one public and private subnet in one availability zone and one public and private subnet in another availability zone. So why we are doing that is because having availability zone, the entire concept of that was that if one availability zone goes down, you'll have another subnet and other set of resources available in another availability zone to support you. Okay, which is why this wizard makes sense, but we will not be able to replicate this end to end. Now, to replicate this end to end, we'll go ahead and manually create this entire infrastructure. It's taking some time. Let's wait for it real quick. Or I can go ahead and create another VPC. Okay, this VPC is in progress. By the time this is going through, let me go ahead and create another VPC manually. Okay, manually as in all of these resources that it created automatically, I'll create it manually. Okay, it's already created now. So you can see the VPC. If you see the VPC, this is what the VPC related architecture is. Okay, you can go ahead and check the routing. You can go ahead and check the route table, NAT gateways and everything. This is the resource map basically. And this is how the subnets will look like here. We have one public subnet, one private subnet. As I mentioned, both of them, a subnet is public and private, or is proclaimed public or private only after you check the route table. Okay, because this name doesn't signify anything. Okay, until and unless this route table has a route to IGW, it doesn't make sense, which it does have. So we are good to go. Second thing, a public subnet is by default, a private subnet is by default private only, but to actually give it connection to internet, as in if resources are available, or if you create an EC2 instance or an instance or a server in private subnet, then Also, you might need some internet connectivity to actually reach some external server, get some packages, install some packages. Example, I want to install Nginx, Apache, something on the server. Then what do we generally do? We connect to either yum repo, public yum repo, or apt repo, and then go ahead and install it from there. So since we need that connectivity, like external connectivity, we want to have that NAT gateway there. It's very similar to the router that you have in your machines, you have at your places, because that as soon as you try to connect to that router will give you an IP using DHCP, and then you can access internet from your system via that router. But can anybody in the world reach you via that router, via that IP, until and unless it is giving a public IP to you, or you are attaching a public IP? It will not be reachable. Okay, if you have a public IP, which it does give, then then your machine will be reachable via internet. Okay, but that is again a safety like glitch if that does happen. Okay, now after creating VPC via a wizard, I will like to create everything manually. So I'll delete this VPC quickly. Okay, it says it just needs us to go ahead and delete these interfaces before I can go ahead and before it can go ahead and delete the resource. So I'll just come here, actions, delete. It will not allow me to delete, so I'll detach first. No, it's not allowing me to detach. Let me just delete the NAT gateway first. This is Elastic IP connected to the NAT gateway, I guess. It's a NAT gateway interface. So if I delete NAT gateway, then I can, after that is successfully deleted, I can come here and delete this one. Now, why I'm sharing deletion steps also, because you should understand and should be able to traverse the part. Every NAT gateway is given a public IP, so that's what you'll see here, and Elastic IP that you'll have to manually go ahead and release. Now let me go ahead, by the time this is getting deleted, let me go ahead and create a VPC manually as we did last time. Okay. Now, when I create this VPC manually, as in I'm trying to create all of these resources manually. So DevOps course manual. In this, I'll be giving same route, same CIDR. It is just asking me whether it is a default, like whether I want to go for a default tenancy or a dedicated one. I'm going for a default one. Dedicated one, of course, as the name suggests, it's going to be higher in charge. Okay. So as soon as I delete that, I deleted the NAT gateway. I think it takes time. Create a VPC. So this is the wizard that this is manual creation of everything that I'm doing. Now now I need two subnets. Can you see this diagram? Where is that diagram? I have created a VPC, a simple VPC. Okay, manually, not via wizard. Manually, I've created a VPC which has DevOps course manual written there. Now I'm creating a subnet here. Okay. I'll select the VPC wherein I want to create this subnet. I can decide whatever name I want to give for this. My preference is this region. This is VPC CIDR, so I won't be able to change it. Okay. I have created a subnet. I will create the second subnet that is going to be my private one. As I already mentioned, a subnet is public or private based on whether it is connected to internet gateway or NAT gateway or nothing. If it is connected to neither internet gateway or NAT gateway, then it will not have any kind of internet access. Okay.
Yeah, okay.
So in this case, I'll write private. Now my preference is going to be this. That's what I've explained initially, that liberty Wizard will not give you, that you can create one wherever you want to create, whichever availability zone you want to create. It doesn't give that functionality. In this case, you'll have to. But in this case, when it comes to when you're manually creating stuff, you can create stuff wherever you want to. Okay. So now I have two subnets that I've created for this. Now, next thing that I want to create is this internet gateway. You see here. So I'll just come to my DevOps course manual IGW. Create an internet gateway. So I've created this internet gateway. Now I have to create a NAT gateway. I'll come here and create a NAT gateway. There are two things that are available. One is NAT gateway and okay, it's asking me whether I want to attach this internet gateway to this VPC. Attach. This is the internet gateway that I've just created. I can just go back. This is the internet gateway that I have created currently. I can go here and attach it to my VPC, which I want to attach it to. Which I have
So this NAT gateway should be connected to internet gateway, is it? Or it is just
no. NAT gateway currently, if you see here, let's look at the diagram. Is internet gateway connected to NAT gateway? No. NAT gateway is placed in the subnet which is connected to internet gateway. Why? Because this needs access to internet, and access to internet or gateway to internet is only available via this.
okay.
So this NAT gateway is placed, as I already mentioned, any resource that is placed in public subnet, okay, will be number one, it will have a public IP, which it had, okay, NAT gateway. And second thing, it will be able to reach internet, and internet will be able to reach this. Okay.
Okay, so the route table there, that is to that helps in
Do this attachment and make that understanding. So me saying it will not actually happen, right? So to actually convey the same, route table is something that happens there. Okay. It's very similar to router, if you have heard of. So in router also, if you have connected like a router also does something like similar. Whenever your request from your machine goes to a proper route or a router, what I would say,
so it means assume there is
like it has a logic or a tabular logic to be able to traverse the request and parse the request and send the request in certain direction.
no, what I mean is, suppose there are resources in public subnet that will connect to internet gateway, and for that still we need to use the router for the config to connect. And the resources which are in the private subnet, that will have to connect first to the NAT gateway, and NAT gateway will have the configuration to connect to the internet. Am I right or wrong?
Yeah. So this NAT gateway is only created for public subnets, because if you see here, for private subnets, because this NAT gateway will open connectivity from this private subnet. So what will happen? Any request coming in from private subnet will first go to NAT gateway. NAT gateway will look at its route table and see, okay, where exactly should I pass this request to? Then okay, private subnet will actually send that request to NAT gateway, and then accordingly NAT gateway will send that request outside to internet via internet gateway.
Okay, okay.
That's why it is placed there. So if you see here, when I am creating a NAT gateway, okay, it is asking me for a subnet. You read this, it is created for private subnet, but it is placed in a public subnet. Why? Select a subnet in which to create a NAT gateway. If you now create a NAT gateway in private subnet, it will not have connectivity to IGW. If it will not have connectivity to IGW, because this is not connected to IGW directly. So if it is not connected to IGW, it will not be able to reach internet only. So it will not, the purpose of having that NAT will no longer be of use. Why this NAT is there? Because it is doing IP scraping also for you. Any internal request, okay, has, like, if you have seen the packet, it will have the source IP, destination IP, and others. So source IP is something that cannot be given out to an outside world, right? So what we do is, this packet goes to NAT gateway. NAT gateway will change the, will open the packet, change the source IP, and will send it to IGW. Then IGW IGW will send it to internet. Internet will process the request, send it back to NAT gateway. Why? Because it has the source IP of that NAT gateway, which is going to be this elastic IP allocation which I am doing.
Okay.
Okay. And then this request, when it comes back to NAT gateway will process the request and send it back to the original source where it should be. It should be sent to, or who has actually initiated that request.
Okay. Yeah.
Okay. Now I've created a NAT gateway. After creating a NAT gateway, if you see here, second thing that we have to do is update these route tables. So let me go ahead and create 2 route tables. Why I'm creating 2 different route tables rather than using the default one is because I want to have some like bifurcation. I don't want to I want my route tables to be with the name only you should be able to identify. So that's why we keep the name very, very similar to what it is trying to achieve. Public route table. In public route table, what do? We attach in IGW here. Okay. If you see here, it is public subnet. It is attached to this route table is attached to IGW. Now, if you come here for private, it is attached to NAT gateway. So I'll create one more route table here.
So route table is attached to basically a VPC. I mean, it's not something to do with private or public. I mean, it's not like residing in a private or public subnet. It's something a part of VPC we can consider.
Let's see what it is trying to do first. Okay. Let me see what I'm trying. Let's see what I'm trying to do, and then I'll explain the same thing. I think most of the things will be answered. Now, I created a VPC. In that, I created 2 subnets. Outside that, I'm creating 2 route tables. One route table is sending traffic to IGW, which will be internet directly. Okay. And another route table is sending the traffic to NAT gateway. NAT gateway, to NAT gateway. Okay. The NAT gateway, however it processes. If it doesn't process that request, it will not process that request if it doesn't understand. Okay.
Okay.
Now, for making this particular subnet public or private, public means available for public. Okay. So a chair. Okay. When I see a chair, do I say, is it public? Is it a public property or a private property? By seeing a chair, can you say that? No, right? until and unless you know where it is placed or where it is kept, right? If it is kept in a park or a ground, it is a public chair or a public property. If it is kept in your house, your place, that means it is a private property. Chair where I'm sitting, it's a private property. Chair which is kept outside, or sofas which are kept outside, okay, they are public property. Okay. Now similarly, a public subnet will become public only when it is accessible to everyone via internet. So to make it accessible to everyone, we have something called as route tables. These route tables help this subnet understand how to process a certain request. Example, if some source or some packet is coming here, okay, it will go to the, it will open that packet and see, okay, it is coming from this, so it is coming, going to this source, destination. Okay, if destination is google.com, does it match to this one? No, because it is the internal routing request only. So now to actually fix this, we will attach this particular route table that we have just created, which has a route or which has an understanding to process all the other requests apart from this request to send it to internet. Okay, something. So I'm associating it with this subnet. If I associate it with private subnet also, then private subnet will also become public only. Okay, whatever is the name, it doesn't matter. Work matters, right? It is my it is my private property, but if it is kept outside, it is public, right? Anybody can go ahead and sit there. Same, when this is now, I'm attaching this to a private subnet, then this private subnet will become private but will have access to internet via NAT gateway. So how will a network packet will be processed is something that is explained in the route table. So what it does is it will open the packet, see, okay, destination is 8.8.8.8, which is google.com. Does it match the local network? No, it doesn't match the local network, so no, local target will not be processed. Okay, now apart from local network, I am saying 0.0.0.0, which means that anything apart from that, okay, will go to IGW. So what I'll do, I'll send this packet to IGW. Now IGW will process it and send it to internet and all of that. But my task is just to put this particular packet at the right location looking at the table. Okay, example, if I say that there are 2 rooms, okay, people from my company send it to this room. People from apart from my company send it to this room. Now, what I'm explaining here is that table. Okay, if your destination is my company, come here. If your destination is somebody else, send it here. If I say that if a person is coming for my company, send it to this room, then only requests that are coming in from my company will be processed. Other requests will be sent back. That's what a receptionist does, right? So consider this as a route, okay, or a rule which identifies how will a request be processed when it reaches this particular component. Okay, so now when I come to this, I'll see the route table and see, okay, it has IGW. Again, when I'll go to private, it has NAT. So which means I have almost done everything that this wanted to do, apart from creating these host, bash and host and MySQL, which we'll be doing later. Okay. Now, when it comes to processing these requests, we'll take it tomorrow, because then now in tomorrow's class, we'll be creating a VPC and then we'll be creating an EC2 instances in these 2 VPCs. Okay. And try to remove certain routes and change certain routes and see how is my process getting request. Okay. So we'll see that and try to see how this processing actually happens. Okay. Because don't take my word on this always, because I want you to question stuff. If you are questioning it, that means we can like definitely learn something more than what we should be learning in the class. Okay.
Okay.
Anything else, guys? Anything else I can help you with? Any questions?
So need more, I think, hands-on practice on this.
Correct. So what I would request is whatever we are doing in the class, please go ahead and do all of that on your own AWS account also. Only one suggestion: whenever you are creating anything in your AWS account, make sure you're deleting it on time, because every resource that you're creating, it's chargeable. Again, as we discussed, we are actually tenants of AWS here, right? So whatever we like, it's very similar to renting an apartment. So whatever time you're staying in that apartment, you'll have to pay. Okay, if you rent an apartment but don't live in it, okay, still your landlord will ask for money. Same thing, AWS, if you have created a resource and even if you're not using it, it will still be chargeable. Okay, so every resource that you're creating, please clean up that from your account until, if you are sure that you're going to use it, then keep it for some time. If you are sure that you're not going to be using it and next time you can go ahead and quickly create it also, then that kind of saves the cost. In fact, if I tell you, lot of companies also does the same.